hopefully it's actually sharing. I don't know if it is or not. All right, I'm gonna slide me over here. All right, hey, welcome back, everybody. We're gonna try this remote week. We'll see how this goes. So I'm basically just gonna do what we would be doing in class, because see, you're supposed to have turned this in already. Ionic compounds, naming worksheet number 4. Now, here's 4. Here's the thing. I don't know if you actually did this, or if you hadn't done it. If you hadn't actually tried this yourself, then watching this video is probably not going to be a great idea. If you did not actually do this, I would probably pause this. Try to do this. Now, on the screen here, I don't have the questions all written down. I wrote down which ions we're supposed to pair together to make a compound, but we even have to just get the table filled in before we can even do that. So if you did not at least try this, I would pause, go try this, and then watch this to see if you're thinking correctly. If you did do the whole thing and you're ready to go and you just need to see if you did it right, well then continue watching. But yeah, it won't do you much good if you didn't do it, didn't try, and then you just watch me do this and you'll be, oh yeah, I know how to do that, but then you don't really. So take a look. Try it yourself first. All right, so in terms of oxidation numbers, ion symbols, and ion names, those are things that we were working on before. Remember, oxidation number is on the top of the periodic table that I gave you, the pluses and minuses. The ion symbol is the element symbol with the oxidation number as a superscript. And then the ion name, remember, the negative ones have a name change. The negative ones, the name changes, the suffix becomes "ide." The positive ones, the names don't change. So if we look at this, we have potassium. Potassium, oxidation number is a +1. It's an alkali metal. Oh no, I need my, oh gosh. Now I got to get me out of the way. Oh, jeez. Oh boy. This video is probably going to take longer than it should because what is going on? Okay. Oh my gosh. +1. Oxidation number is +1 for potassium because it's an alkali metal. And then we have an ion symbol. That means it's K because that's a symbol for potassium. But I see people keep putting P. P is not potassium, that's phosphorus. So it's K is the symbol with a +1 superscript up like this. Now, we did find out if you wanted to do this on the Google form and not have to actually write this in your comp book, which I'm sure some of you turned it in that way, if you use control period, I think, is superscript, and control comma is subscript, I think, if I remember correctly. So try that if you haven't. And ion name, since it's a positive one, the name doesn't change. It's just potassium. And nitrogen. If you look at the table, that's a -3. Oxidation number, -3. And that would be an N with a -3 superscript. And that would have a name change because it's negative. And so that name change is an "ide" on the ending. So we lose the ogen, ogen, and it's just nitride. Nitride. We lose the ogen. And then we have bromine, which is also a negative. It's a -1. It's a halogen all the way on the right side there next to the noble gases. And that would be a Br with a -1 superscript. And that also would have a name change. And so INE falls off and we put IDE in its place. So instead of bromine, it's bromide, like so. And then aluminum, which is over by boron, that is an oxidation number of +3, which is an Al +3 superscript. And since it's positive, the name doesn't change. Okay, so that's what your table should look like. That, hopefully, you were able to find. I mean, this stuff is on the periodic table. The symbols are on the periodic table that you just have to put your oxidation numbers attached to as superscripts. And then we have the names. Remember, negative ones change, positive ones don't. So 1 and 2, we're supposed to put ions 1 and 2 together in a compound. So what if potassium and nitrogen get together to form a compound? They want to know, I believe, the formula. Let me look at the worksheet here. The formula and then the name. Formula first, then the name. Now, when we had this conversation in class, how do you know which one goes first? How do you know which one to list first in the formula and in the name? Now, I told you in class, but I don't know if you remember. How are you supposed to know which one goes first? Positive, always first. All right, it's always positive first, negative second. And that's both in formula and name. All right, so numbers 1 and 2, potassium and nitrogen. Okay, so I will list them. In fact, I'm going to put the ion symbols of each of them so I can look at that. So we have K, and then we have N minus 3. We have a K plus 1 and an N minus 3. So how can those two make a neutral compound together with one of them's a plus 3 or plus 1 and one of them's a minus 3? I hope you're thinking, like, to make those numbers work, we need 3 of the plus 1s to cancel out 1 of the minus 3s. We need 3 plus 1s to cancel 1 of the plus or the minus 3. Did I say that backward? 3 of the plus 1s to cancel 1 of the minus 3s. So it has to be K3N. We need 3 potassiums to cancel the plus 3 or the minus 3 of nitrogen. Man, I'm having a hard time. Now, something else I had shown you in class at the very end, I think, last time we were there, is I showed you if you take the oxidation numbers and you cross them over to the bottom on the opposite side, it tells you what the subscripts have to be in your formula. That means the 3 goes down here, the 1 goes down here, and then that gives you K3N. See that? The pluses and minuses don't stay. Just the 1 and the 3 cross over and go below. That has to be the formula. Let me get that thing out of the way. Now, what's the name? If 1 and 2 combine to form a compound, then the name is literally just the name of the ions. It's potassium nitride. That's it. Potassium nitride. That would be the name of K3N. Formula is K3N. Name is potassium nitride. All right, moving on. 1 and 3. Hopefully the rest of these go a little faster. 1 and 3. We have to combine 1 and 3. 1 is potassium still. 3 is bromine. Okay. So we have a K plus 1, and we have a Br minus 1. So we have a K plus 1 and a Br minus 1. How's that going to work? Let me move me here back in the middle. So how's that going to happen? If 1's plus 1, 1's minus 1, we have equal oxidation numbers that are opposite, then we have just 1 of each, right? Easy formula. There's no multiples, 1 of each. So it's just K. Oh my gosh, now I lost my pen. K Br. That's it, KBr. Now, what's the name? Well, it's potassium bromide. It's just the names that you already wrote in the table. Potassium bromide. There's that one. All right, now 2 and 4 have to get together, 2 and 4. So what if nitrogen and aluminum get together? Nitrogen and aluminum. Now here's going to be the tendency, and maybe you did this on your worksheet, I don't know. Since nitrogen is listed first, some of you probably put N first and then Al second in your list here. But remember, which one goes first? What does it say? Positive first. Negative goes second. So when we see that 2 and 4 are going to get together, I have to write aluminum first. Okay. Aluminum has to be listed first. So aluminum plus 3 with an N minus 3. So since 2 and 4, it's, again, Al plus 3, N minus 3. That's what this one is. So notice they have the same oxidation number, but opposite charge, obviously. We have a plus 3 and a minus 3. How many does it take for each to make neutral? One of each. Hopefully you see that. One of each. And so what's the formula? ALN. That's it. ALN. Remember, first letter is capital, second letter in the symbol is lowercase. That's important too. And what's the name? Well, aluminum bromide. Aluminum bromide. Is that what we just did? No. Oh my gosh, aluminum nitride. I forgot which ones we were even doing. Aluminum nitride. Aluminum nitride. All right, and the next one is 3 and 4. Okay, so now 3 and 4 are going to get together. Oh, let's see, aluminum and bromine. Now, again, the positive one listed first, so aluminum is first. So we have Al plus 3 with bromine this time, Br, a minus 1. So we have a plus 3 and a minus 1. Plus 3 minus 1. That means we need 3 of the minus 1s to cancel out the plus 3. 3 of the minus 1s to cancel the plus 3. Right? So it's going to be Al, only one of them. But then how many Brs? 3 of them. We need 3 Brs, 3 bromines, 3 minus 1s to cancel the plus 3. AlBr3. And what's the name? Aluminum bromide. That's it. Just the names that you already wrote down. Aluminum bromide. Now, let me ask a question here. And I didn't ask you this, could I have you put 2 and 3 together? Like, I didn't have you combine 2 and 3 to make a compound. Can you combine 2 and 3 and make a compound? An ionic compound? I hope you're thinking of an answer. You have a minus 3 and a minus 1. Can those combine to form a neutral ionic compound? The answer is no. They're both negative. What do like charges do? Like charges repel. They will not attract and form a compound because they're not oppositely charged. Can 1 and 4 combine to form a compound? Can potassium and aluminum form a compound together? No, because one is a plus and the other is a plus. They're both positives. They're not going to attract. They're going to repel. It's only opposites that attract. Okay, that's what ionic compounds do. Oppositely charged ions that combine because of their mutual attraction. All right, so there's that. And lastly, there was another thing here. Oh, let's see. I got to get this stupid thing out of my way. You can't even see that thing, but it's in my way. All right, the last 2 questions. It says, what is the correct formula for sodium phosphide? So now they gave us a name, and you have to work backward to the formula. So sodium phosphide. All right, sodium, the name. Oh, no. Sodium phosphide. All right, sodium phosphide. Here's what I would do, okay? I don't know if you did this or not. I would write the ion symbols down for these. Write down the ion symbols. What is the ion symbol for sodium? That means you have to be able to look it up, find it on the table, and know what the oxidation number is, and write the ion symbol. So sodium ion symbol is Na plus 1. The phosphide symbol is P, right? P, and that's a -3. So we have Na plus 1 and we have a P minus 3. If those two things are going to combine to make a neutral compound, then we have to have what? We have a -3 over here, but we only have a +1 over here. We need 3 of the +1s to cancel the -3 of phosphorus. So it's going to take 3 sodiums to only 1 phosphorus. So the formula has to be Na3P. Na3P. Now, remember, this also works. If you take the 3 down here and you take the 1 over here, that means we need only 1 phosphorus and we need 3 sodiums. So it can tell you, by crossing them over, it'll tell you what your subscripts have to be. So only by looking at the name, we can then figure out what the formula has to be, because we have to look at the oxidation numbers. You have to know the oxidation numbers, or you can't know how they're going to balance out the charge and make neutral. Okay, last one, finally. Number 10. What is the correct formula for magnesium sulfide? Magnesium sulfide. Magnesium, oh gosh. Oh no. Magnesium, I just butchered, oh jeez. I can't even get the eraser. Sulfide. Did I say sulfide? Yes, magnesium sulfide. All right, so we need the ion symbols of each. Magnesium is Mg, and that's a +2. Sulfur, sulfide, is an S, and that's a -2. So we have a +2 and a -2. How are those going to work? +2 and a -2. +2, -2. One of each, right? One of each balances. We don't need multiples, one of each. So the formula has to be MgS, no subscripts, because they're already balanced. One of each does it. So by looking at the name, going for the ion symbols, that will tell you what the formula is. So you can start with, like up here, just the names of the elements and then figure out how they combine. Or we can give you the name of the actual compound, and then you can work backward looking at the ion symbols and then figuring out what the formula would have to be as a result. So hopefully that makes sense. This is the end of the ionic part. Like the next class, I'm going to have to talk to you about the covalent part. All right. And that's going to seem similar, but there's some major differences in it. And I apologize that this video took so long. But hopefully, watching this video, looking at the work that you did, I'm hoping that you were able to make sense of maybe things that were confusing before, or maybe it just confirmed that you already understand it and know what you're doing. Either way, if you have any questions, then don't hesitate to either email me or ask, or in the Zoom for the next class, make sure to ask and we can discuss that. But I'm going to try in the next class. I'm not sure how much I'll talk to you in the Zoom or how much I'll have a video, but between the two of them, hopefully we can get you what you need to have. So anyway, I hope you're doing well. I hope you had a great holiday and a great break. And I'll look forward to seeing you in person again. And of course, I'll see you on Zoom as well. So anyway, take care. Until next time, be safe.